Hey everyone, my name is Nick, and today I'm excited to present the advancements I have achieved in our data management and analysis capabilities in preparation for the upcoming statewide election in Georgia. My focus has been to leverage cutting edge data tools to gain a deeper understanding of the demographics of our voting age population, aiming to enhance our campaign strategies effectively. The primary goal of this project was to refine our analysis of race and age demographics amongst eligible voters across Georgia. I utilized the 2022 American Community Survey one-year estimates, which provides a rich data set on various demographic attributes. I sourced this data directly from the U.S. Census Bureau's website. This data set, known as Table S2901, covers a wide range of demographic details, including age, sex, race, and educational attainment, specific to the voting age population. So I navigated here, I added my Georgia and then all the counties within Georgia, and then downloaded the table data. I then imported the data into BigQuery, and this process involved several detailed steps, which was an initial data import, which was a raw CSV file. I imported into BigQuery and created a preliminary table that contained all the raw data as it was structured in the ACS website. So you can see this is the schema, and then this is a bit of a detailed view of the data. Go ahead and move this up a little bit so you can see it has all the counties. It has total estimates of 18 and older, also has like race and gender, another demographic information in here as well, age. So I also did some data cleaning to enhance the data usability. That process involved removing rows that contained header information or other erroneous entries that could skew our analysis. I also renamed some of the columns from generic headers to more descriptive ones, such as geography or estimate total citizens 18 and over, which made the data more accessible for analysis. And I also changed the data types where necessary, converting string representations of numbers into actual number and numeric data types, which is really essential to do any sort of analysis or aggregation. And so my hypothesis for this project, to determine if the values in my data set add up correctly, I need to sum the values of each category, so age groups and gender, and compare them with the total population count. I did some initial manual checks for each category, and based on my initial results, both of the sums of the age groups and the gender categories correctly added up to the overall report total population of citizens 18 years and older in Georgia. So this suggests that the data entries for these categories are consistent within the data set. And I wanted to use another data tool to further verify this. So I used DBT, data build tool, to test and validate the data. So I'm going to go ahead and navigate here. So my DBT setup for this project included creating a new project folder, which is right here. And, I installed Vim, I installed DBT and BigQuery. I checked the version, and then also configured a profiles.yaml, as well as a dbt project.yaml, which, I updated the name, BQDBT. And then for my models, I also added the materialized view SQL file that I'll go over shortly. I also created a packages.yaml file, which I'll explain a little bit in a little bit. And then I also just ran and finished my OAuth setups for BigQuery. And then I did some testing of the connection to make sure that my DBT project and BigQuery were effectively synced up. So I do DBT debug. And when I run that, I can see that all checks passed and that my connection is successful. From there, I wrote custom DBT tests to ensure that all disaggregated demographic values correctly summed up to match the total reported populations. So this included checking sums of different age groups and genders against their respective total figures to catch any discrepancies. So I created a SQL file that instructs DBT to materialize the output of this model as a view. So this means that the SQL queries will be stored as a view in the BigQuery database, allowing for repeated use without the need to re-execute the computation. There was also some data preparation that I did in the base data. So this is a CTE that pulls out the relevant demographic data about the voting age population from a source table, right? My source table stored in BigQuery. And then I had some additional aggregation logic that created a Boolean column for age sum matches and gender sum matches that checks if the sum values of those respective categories match the total population count reported. And so when I did my DBT run, you can see that it created a materialized view of those results from that SQL file. So we have the geographic area name, we have the total population, the calculated total by age and gender, they all matched up. So we see that the age sum match and the gender sum matches are all true. I then created a YAML file to define the metadata and testing configurations for my model within the DBT project. And so to break it down a little bit more, I have my model configurations, which includes the name of that view. And that name matches exactly with my SQL file. There's also a description of what the model represents. And for this model, this description is that, I'm summing the age and gender groups and comparing against the total populations. There's also the data tests, which are to be applied to the model to ensure that data integrity and accuracy. So I use DBT utils expression is true, which is a generic test provided by the DBT utils package. So you can see the package right here, the one that I was talking about earlier. Just import this and run this in order to use that package. And the first test checks if the total population by age, which is total population equals calculated total by age, matches the overall total population as recorded in the data. So you see that right here, total population equals calculated total by age. And the second test verifies the same thing for gender as well. And this test helps verify that the sum of the segmented age groups accurately adds up to the total population figure, so ensuring there's no discrepancies. So now that I have my models directory with my SQL and YAML file set up correctly, I have my project packages and profiles.yaml set up correctly. I'm going to go ahead and run a few commands. So I first run dbt clean, which cleans out my target and run folders to ensure I have a clean run. Then I do dbt deps, which installs the DBT utils package for that YAML file that I was talking about. I do my DBT run, that creates a materialized view, and I did it earlier when I shared the BigQuery, but I'm just doing it again for these purposes. So you can see that completed successfully. Then I'm going to do my DBT test to compare the total population to age and gender. So the displayed results show that has completed successfully and has passed those specific data tests, which validates the accuracy of the data transformations and calculations defined in that SQL model. So everything's successful in the conditions of that model. And just to make sure that this is working, I'm going to go ahead and change this up to just show if it were to fail, what it will look like. So let's say I forgot to add the age 45 to 64 within my age calculations. And then I ran that clean command, reinstalled that package, and then I ran the dbt run command. you can see that it'll complete successfully, but then when I rerun my materialized view, you'll see that because that age of 45 to 60 has changed, it's changed the total number of age, right? Made it a lot less than it was before, which means that the age matches are now false. And so when I run my DBT test, you'll go ahead and see that one of my tests failed, which was at age one, but the other one, gender, still passed. Right, so that shows that my DBT model is working correctly and as expected. From here, I'd then create a visualization using Tableau to further visualize the data and write up a report to share valuable insights. And to sum it up, this is my first time using DBT, in which I had a bit of debugging to do in the beginning because it was my first time, but overall I was very happy to get it up and running in the end. And I want to thank Generation Data, Change the Game, as well as my peers for an amazing data engineering academy, and making this a memorable experience. So thank you.